All right, so here I have a little scenario. I have a story, or I have what somebody did in the lab, which is very similar to what you did in the lab. And I have to create an equation from this scenario, and then I have to solve a problem from my balanced equation. So I'm going to read this and find out what my reactants are. Magnesium reacts with oxygen, and what my product is. So I know that magnesium reacts with oxygen, which is diatomic, and it makes magnesium oxide. And I know magnesium's +2 and oxygen's -2, so that happens to be a 1-to-1 ratio, so MgO. Then I look at this and I say, well, that's not balanced. I can't start with 2 oxygens and end with 1, so I have to balance it. I'm going to end with 2 MgOs. That means I better start with 2 Mgs. So now everything's balanced. Moving right along here. Now I have to solve the problem. It says what mass of magnesium oxide can I make if I start with a 5-gram piece of magnesium. So we're going to start with the magnesium. I want magnesium to cancel, so I put it here. And the question says, what mass of magnesium oxide am I going to make? So I put that there. Now, I'm not going to create this big, gigantic table. I'm not going to fill out every single box if I only need 2 numbers. I need the mass of the magnesium oxide and the mass of the magnesium. So let's work these guys out. What I recommend is looking at the formula and figuring out what one of these weighs, then multiply it by the coefficient. So magnesium is 24.3, oxygen 16.0. You add them up, and it's 40.3. That's what 1 magnesium oxide weighs, but the balanced equation here says the ideal ratio involves making 2 moles of this. So 2 times that is 80.6. And then if I want to make this, I better start with 2 moles of magnesium. But I can't go in the stockroom and weigh out 2 moles. I need to get the mass. We know one of these is 24.3. 2 of them is doubling it, so it's 48.6. 5 times this divided by this equals 8.29 grams of magnesium. So if I was looking at a graph here, the magnesium 5 grams sample, 5-gram piece of magnesium would hit 0. It would go down and hit 0 when the magnesium oxide hits 8.29 gram point magnesium oxide. So this is how much product I can make when all of my magnesium is used up, and we assume there's enough oxygen in the air. We're not limited. Let's do the next one here. All right, consider the following reaction. A student drops a piece of calcium in a beaker of water. He produces 15.6 grams of calcium hydroxide and an undetermined amount of hydrogen gas. So we just don't worry about the hydrogen gas. We know it's made, we don't care how much. What was the mass of the original piece of calcium? So the kid put calcium in water, and he made calcium hydroxide. Now we have to know the formula for calcium hydroxide. Calcium's +2, hydroxide is OH -1. So you need to write a number after a polyatomic, which means the polyatomic goes in parentheses. So that's calcium hydroxide. And an undetermined amount of hydrogen gas. Don't forget this because it'll be impossible to balance. H2. So now, 1 calcium, that looks good. We've got water and we've got hydroxide. A tip, whenever you have water on one side and hydroxide on the other, is to rewrite water. Write it as HOH. So now if I relook at this, calcium's good, calcium. 2 hydroxide, I've only got 1 here. Let's make it 2. So now I got 2 hydroxides. That's good. And then H2, well, look at this. 2 times H. I'm good. So all I need really is a coefficient right there in front of my water. So that little hydroxide hydrogen business helps. All right, write a balanced equation. We did that. We're not going to create a whole big table because we have only one little problem to solve. We know we're going to start with the number given to you in the problem, 15.6 grams of calcium hydroxide. Make sure you write a number, a unit, and a formula. Get it down here because we want it to cancel out. And then what are we looking for on top? What's the mass of the original piece of calcium? How much did this kid put in there? So grams of calcium. So then we look at our balanced equation and we say, what would these numbers be if I did fill out a table? Well, there's only 1 calcium. So you look on the periodic table and it's 40.1. Easy enough. And then we have 1 calcium hydroxide. So add up 1 calcium and 2 hydroxides, or you could distribute 2 oxygens, 2 hydrogens. Either way, when you add that all up, remember we only need 1 mole, when you add it all up, it comes out to 74.1. So this times that divided by that equals 8.44 grams of calcium. So when the kid dropped in 8.44 grams calcium, this is what was produced. We assume everything went perfect here. But that's the amount of product when this was the amount of reactant. And we actually use the product to figure out the reactant size. Usually it's the other way around. All right, let's come back in a different video for number 5. Let me stop this one here.